Hi. Was this the first time you're hearing my voice since we've been working from home? I think so. Anyway, we're going to look again today at adding fractions with a different denominator. So you looked at the White Rose home learning lesson, which showed it you through bar models and through lots of different representations, so a grid sort of method. And I got a little bit of feedback that it wasn't the simplest thing, and I agree, it's not a way I've taught it before, so I want to kind of show the traditional way of how I was taught it and how I would do it myself, and you can choose which way you like the best. But it's great to have more than one method of doing something, isn't it? So we can see, so from the first video you'll see that you need to be really good at your lowest common multiples for this. And that is because we need something called a common denominator. And denominator is the bottom number on a fraction. So the denominator here would be 4, and the denominator here would be 2. These aren't common, they're not the same number. So what can we do to 2 to make it like 4? Well, if I times 2 by 2, so I'm going to times it by 2, I can make that be common. We've both got 4's on the bottom, and we know when we've got the same number on the bottom, we can just add the numbers on the top. We've already looked at a lesson like that. However, I can't just put a 1 here. I can't just do that, because 1/4 and a half, they're not the same thing. I'm not allowed to change this fraction. I just want to change how it looks. So right now I've got a half shaded in. That's what this fraction here represents a half. But I want to turn it into quarters. So what I've done, making that out of 4, I've made it into 1, 2, 3, 4 pieces. And what that is, well, that's 2 pieces. And can you see that actually that is times by 2 as well? So what we need to do is we need to multiply the top and the bottom by the same number. Multiply top and bottom by the same number. And that's how we keep the fraction exactly the same, just written differently. So instead of writing a half, we've written 2/4. And then from this step, well, we can go and we can say, well, 1/4 plus 2/4, this is 1/4, this is 2/4, it would be 3/4. I've done 1, add 2, gives me 3. Okay, a couple more examples. Maybe when you gain some confidence in what I'm doing, you can give it a pause and see if you can beat me to it. So I want to make this 4 into an 8. So I want this to be something out of 8, and this 1/8 is going to be the same. What have I done to get from 4 to 8? Well, I've done 4 times 2. So I need to do 2 times 2. And that is 4/8. You can always draw yourself a little diagram like I did with my circle in the top left to convince yourself that we're not changing it, we're just changing how it looks on the paper. And then from here, it's going to be 5/8. Okay, looking at my 4 times tables, 4, 8, 12. That is my number that's common to here. So I want these to be both out of 12. This is still going to be 5/12 because I'm not changing that at all. What have I times 4 by to get 12? Well, I've timesed it by 3. So I need to times the top by 3 as well. So 1 times 3 is 3. And then when I finally add these, I'm going to do 3/12 plus 5/12 is 8/12. And sometimes you might be asked to write it in its simplest form. We can simplify this. 8/12. Well, what can we divide these both by? I know I can divide them both by 2. So why don't we divide both numbers by 2? Put that in a little bracket. 8 divided by 2 is 4, and 12 divided by 2 is 6. They're both even numbers again. I can do it again. Let's divide by 2 again. And this will be 2, 3. So actually, we could say the answer is 8/12. We could also, if we want to be a little bit better, we could say the answer is 2/3. I know you had a question like that on your ED quiz where it said write in the simplest form. Okay, and I've got 2 more examples and then some questions for you to have a go at. So maybe you want to have a pause now and see if you can have a go, or you might even want to have a go at question 4 and 5 there. But I'm going to go through them now. So, I want this 7 to be the 14, because I know 7 times tables goes 7, 14. Ah, they're common. So I want them to both be over 14. To get from 7 to 14, I've times by 2. So I'm going to times 3 by 2 as well, always times in the top and bottom by the same thing. And that would be 6. So when I add these together, that is 7 over 14. Can you simplify it? Well, hopefully if you simplified it properly, you would have got a half. We can divide both of them numbers by 7. Okay, and then final example from me. Let's list our 2 times tables. Always check to see if the smaller number can go into the bigger number. Oh yeah, it is. So I want to get these to both be over 8. The one that's already over 8 isn't going to change, keeping that fraction exactly the same. 2 to get to 8, well I've times that by 4. We're always looking at how much we've timesed it by, never how much we've added on, always times. So we want to times that by 4 as well. 1 times 4 is 4. Add these together is 5/8. Okay, see if you can have a go at these 2, and then I'm going to go through them very quickly afterwards to check if you've got the same answer as me. Okay, hopefully you've had a good go at them. I would make these both over 6. And I've timesed by 2 here, so I'm going to times by 2 on the top as well. So that'll be 2/6. And when I add these together, I'm going to get 3/6. You could also write that as a half. Don't worry if we're struggling on that final step. If you can get 3/6, that is perfect for where you need to be. And then this final one was a little bit tricky. So let's see if our 2 can go into 10. Ah yes, in our 2 times tables, we get to 10. So I want these to both be over 10. This one doesn't change on the right, but this one over 2 does. Well, what have I timesed by? This is 1, 2, 3, 4, 5. So 2 times by 5. So I want to times the top by 5 as well. That would be 5 over 10. So 5 over 10 plus 3 over 10 is 8 over 10. And if you think you can simplify that, or we can divide them both by 2, so we would get 4/5 as our final answer. But 8/10 is also perfectly correct. We're going to do a bit of a challenge question now. So I want to see if even with some help or without any help, I want to see if you can get this question right. You might want to come back to it at the end when you've got a bit more confident. But this is quite hard, I think, but we're going to go through it. Harry has spent 1/2 of his pocket money on a ticket for a football match, hopefully seen Sheffield Wednesday. He spent 1/8 of his pocket money on a scarf at the match, Sheffield Wednesday scarf, I hope still. What fraction of his pocket money has he got left? So, if we represent his pocket money as a bar, and I'm going to split it into 1, 2, 3, 4, 5, 6, 7, 8 pieces. The reason I'm splitting it into 8 pieces is because I know at some stage I'm going to have to do something with an 1/8. And even when I do something with a half, I'm probably going to turn that half into something over 8. So I want 8 pieces to be able to work with this. This whole bar represents his pocket money. So if he spends a half of it on a ticket for a football match, well, a half of it would be right here. So he spends 1, 2, 3, 4 eighths, which is the same as a half, on his pocket money. Of his pocket money on a football match ticket. So this is a ticket. He spends 1/8, so one of these, on a scarf. Scarf, can't spell today. What fraction of his pocket money does he have left? So what he has left are these. So what fraction does he have? Well, he's got 3 out of 8 left. And then, so that's part A. And part B, oh, I've answered part B. Part B is what does he have left, which is that. Sorry. And part A is what has he spent? Well, he spent all of this. He spent 5/8. And what we've done to find that is we've really done a half plus an eighth. A half plus an eighth would be, well, we times this by 4 to get 4/8, and then we add them together, so we get 5/8. And then for me to get 3/8, we did that skill we did a few lessons ago where we took a whole number and we took away a fraction. So we've done 1 take away 5/8, and that is how, through our diagram, we got 3/8. But that's kind of the mathematics behind what I've done there. Okay, hopefully that has helped, and that is all from me.